Hello, CSEC students. Welcome to another live class. Today, we're going to be looking at finding the missing angles of triangles, of circles, straight lines, blah, blah, blah. All right. So we started this actually last week. And this is kind of like a revision course. All right. If you're just joining us though, we'll go through the basics to bring you up to speed. And then we'll work together and find the missing angles. As a reminder, angles in a triangle add up to 180 degrees. Angles on a straight line also add up to 180 degrees. Angles in a circle, all the angles in a circle must add up to 360 degrees. There's also something you should note about the exterior angle of a triangle. It's equal to the sum of the two opposite interior angles. So as we go along, you'll see exactly what we're talking about there. So let's get into it. All right, so so let's say we have this triangle. So we have that triangle, and we are told that this angle is x, and this angle is 2x, this one is also 2x, and this one is y. And we're asked to find each of those angles. We're asked to give the actual degree measurement for each of those angles. So what would be our approach? What would be our approach to finding these missing angles? Any ideas? How would we find the missing angles there? Write your answers in the chat. Or if you have questions that might lead you to finding the answer, write your questions in the chat. Come on, guys. This is the first one. Everybody should be clamoring to give me the answer. How are we going to find those missing angles? So the top angle is x. Yes, so we're going to find x. By the way, I'm curious. What kind of triangle are we looking at? What kind of triangle is that we're looking at? Tell me the name of this triangle. What kind of triangle is it? Yes, that's 2x in the corner. So the top angle is x. The two bottom angles are 2x each. So question, what kind of triangle is it? And second question, how are we going to approach the question? How do we find the missing angles? But I'm shocked. How is it that no answers are coming? All right, so Imani says, Imani? I was about to pronounce that word Imani, that typo. That typo there would twist up my tongue. All right, so Imani is saying it's an isosceles triangle. And how do we know that it is an isosceles triangle, Imani? So if you missed out on the types of triangles, we did a video about the types of triangles. We did a video about types of angles. And we did the first video to this one, finding missing angles. So you can go and check those. All right, so Imani is saying two sides are the same. Well, we're not given any sides here. We're given angles here. But two angles are the same. And by extension, that means two sides are the same. But just to be precise, we're not actually given any sides here, right? So, right, so two angles are the same. In a triangle where we have two angles being the same and one is different, that's an isosceles triangle. All right. So how are we going to find the missing angles now? I thought everybody would be flooding the chat with Miss do this, Miss do that, Miss do this, Miss do, because you guys were like fire last week. You were firing on all cylinders last week. So what's up this week? All right, so let me see what Imani is saying. X plus 2x. You sure, Imani? X plus 2x. Remember, you have an x at the top. You have 2x and 2x down the bottom. All right, so Imani is saying we need to add the x plus 2x plus 2x and make that equal to 180. And that is correct. John is also saying 5x. So since we know that these angles are in the triangle, these three are in the triangle. Angles in a triangle add up to 180 degrees. So x plus 2x plus 2x equal 180. I have a feeling Zion is over there typing him long speech, and then we'll just go and see it appear in the chat. Because that's what he did last week. Zion was explaining everything in detail for us last week. Even when we thought he wasn't coming with anything, he just say boom, and the long explanation appear in the chat. All right, so x plus 2x plus 2x, that's 5x. And that gives us 180. Therefore, x would be 180 divided by 5, which is 36 degrees. So wherever you see x, that's 36 degrees. So that means this angle here is 36 degrees because it's just x. This one here though is 2x. So this one here is 36 times 2, which is what? 72 degrees. And this one is also 72 degrees. All right, so we have those angles down pat. We find these three missing angles. This is 36 because that's just x. This is 2x, so 2 times 36, and this is the same thing. So how do we find y? How do we find angle y now? The exterior angle. And there are at least 2 ways that we can find that one. There are at least 2 ways that we can find that one. Who wants to tell me one of the ways? Who wants to tell me any of the ways we can find? I knew it. Zion come with him long speech there. I knew he was there typing away. All right, so Zion says, to find x, we add the 2x, that's 4x. Oh, but Zion, you missed something. You missed the other x. Remember, you have a x, then a 2x, then a 2x. So it's not 4x, it will be 5x. All right, so Imani is saying y is 108 degrees because she added the 72 plus the 36. And that is correct because because remember we said the exterior angle. Okay, yeah, that was a mistake, Zion. So the exterior angle, so this angle out here, the exterior angle is equal to the sum of the 2 opposite interior angles. The exterior angle is equal to the sum of the 2 opposite angles. So that means we can just add the 36 and the 72. So Imani is correct. So for y, we just add the 72 and the 36, the 2 opposite interior angles, and we get 108. But how else could we have found y? How else could we have found y? There's another way that we could find y, other than to say it is the sum of the 2 opposite interior angles. Which other rule could we have used to find what y is? Who remembers? Remember, we did the rules for angles. Angles in a triangle add up to what? Angles on a straight line add up to what? Angles in a blah, 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 blah. Which one of the rules could we use other than the one that Imani just used, that the exterior angle is equal to the sum of the 2 opposite interior angles? Which other rule? Come on, guys, think. You know this. You know this. So where's all the fire from last week? You guys put out the fire from last week? Everybody was hot last week, you know. All right, so let me remind you of this one because it looked like you guys don't remember this one. So these 2 angles are on a straight line. So that means these 2 angles add up to 180 degrees. So since we've worked out that this one was 72, we could also find y by subtracting the 72 from 180. Angles on a straight line add up to 180. So if you know one of them, take it from the 180 and see we would get back. See, we would get the 108 degrees. So there are 2 ways we could find y. Subtract the 72 from 180 or add this 72 to the 36. Let's go to the next triangle, to the next problem. Oh my God. When am I going to learn to draw a straight line? When? Oh my God. I need some art lessons. And I'm actually a good artist, but it's just this format. All right, I think that will do. So let's say we have this. We want this angle. And we are told that this is 143 degrees. So this is an easy one just to get your juices flowing again. So how are we going to find x? You see what I'm telling you? Okay. How are we going to find x for this problem? Boy, you guys not firing. No, you're not firing no shot today. No shot not fired today. Trust me. Wally pa shot a fire last week and now come back and no shot not fired. All right, so Trevor is saying we are to take 143 from 180. All right, so remember now, so this is the straight line. Angles on a straight line add up to 180 degrees. So if we know this one, we can take it from 180 and we find the x. So Trevor is right, and he's saying that would give 37 degrees. So let's see. So it's the 180 minus the 143, and that would give, so we'd have 7. Okay, so that's correct, Trevor. That will give us 37 degrees. All right, so let's move on. So we have this situation happening here where we have something like that, like that, like that. We want this angle, and this angle is 62 degrees. How are we gonna find this angle? So okay, so Imani is quick on the draw right now. Imani is quick on the draw. Let me see if I see any more answers popping up. Trevor says divide 180 by 2. No, Trevor. No, Trevor. No, Trevor. Think about it some more. So where's Cashmark? Cashmark was blazing some shot last week, So Imani is saying, since angles on a straight line add up to 180, and we know that one of them is 90 degrees because we see that box in the corner there, and we know one of them is 62, so we should add them and subtract from 180. And Jamani is saying the same thing. So this angle here, anytime you see this box there, even without being told, this is a 90-degree angle. It's a right angle once you see that box. So we actually know 2 of the 3 angles. And since they are on a straight line, so we just add the 2 angles that we know and take it from 180. So that would be 62 plus the 90. We know these 2 angles, and that will give 152 degrees. We're going to take that from 180. Angles on a straight line add up to 180 degrees. So we're going to subtract it from the 180. And we're going to be left with 28 degrees. So y is 28 degrees. All right, so we're gone 3 already. 3 down. We're going to do about 12 today. About 12 of them, so 3 gone. All right, so we have our regular triangle. I want you to tell me what kind of triangle is this. When I put in the angle, so let's say this is 100 degrees. And this is 33 degrees. And we want W. First of all, tell me what kind of triangle it is. What kind of triangle is this that we're looking at? And how do we know? Somebody, anybody tell me. What kind of triangle are we looking at? Okay, so Zion had said for the one before, we should add the 90 and the 62 and take it from 180. All right, and that is correct. So even after the questions go, I'm going to read your answers because I know that the chat kind of lags behind. So for this one now that we're looking at, what kind of triangle is it? Zion says it's a scalene triangle. And Imani says it's a scalene triangle. You are both correct. How do we identify a scalene triangle? What are the features, the properties of a scalene triangle? Sajarta also said scalene triangle. All right, so Imani is saying in a scalene triangle, no angles are the same. That's correct. So Ngozi also says no equal sides and by extension, no equal angles. So 3 different angles, 3 different sides. So it's a scalene triangle. All right, so we have that out of the way. We know what kind of triangle it is. How are we going to find W? How are we going to find W? All right, so Trevor says he's back. That means him back in a business because Trevor was blazing some fire last week, you know. All right, so Trevor says you add the 100 and the 33 and you get 133. And Najara is saying the same thing. So Trevor said add the 100 and the 33 and take it from 180. And Najara says add 133 and subtract from 180. And Trevor is even giving us the answer already, which is 47. That is correct because since all the angles must add up to 180, and we know these two, so we just add the 2 that we know, add those 2 that we know already. And that's going to give us 133, as Trevor said. All right. And then now we take that from the 180, since we know all the angles in the triangle must add to 180. All right, so that's gonna give us 47. So W is 47 degrees. Okay, so we're back in business, right, Trevor? So tell me now, look at this one now. Look at this triangle now. So we have this triangle that looks like that. This angle is 4x. This angle is 4x. and this angle is 4x. So first of all, you're going to tell me what kind of triangle are we looking at? What kind of triangle we're dealing with? Sajarta also got 47 for the previous triangle. So for this one, what kind of triangle is this? And how do we know? And then we're going to find the value of x, and you will tell me how many degrees each angle is. Okay, so I'm seeing some answers coming in. So Trevor says it's an equilateral triangle. What are the features of an equilateral triangle? How do we know an equilateral triangle when we see one? Ngozi says it's an equilateral triangle. It has 3 equal sides. Since we are not told any sides, we are given angles here. Even though by extension it means the same thing, 3 equal sides, 3 equal angles. But let's focus on the angles because that's what we're given. So we can see in the diagram that these 3 angles are equal. All right, so Trevor is correct and Ngozi is correct. So it's an equilateral triangle. So what's the value of x? And how many degrees is each of those angles? What's the value of x? And how many degrees is each of those angles? Okay, I'm not seeing anything yet. What's the value of x? Throw in some algebra in it. So Sajarta, you're on the right track. You're on the right track. That's not the answer yet, Sajarta, but you're on the right track. So Sajarta is saying 12x. That's an idea there. It's not the answer, but it can be the way to the answer. So we're looking at a triangle and we are told one angle is 4x. All right, so Imani says 4x plus 4x plus 4x is 180 degrees. Therefore, 12x is 180 degrees, so x is 15 degrees. That's correct. So 4x, we are given 3 angles and each of them is 4x. 4x plus 4x plus 4x, or we could have said 3 times 4x is equal to 180 degrees. Therefore, so 3 times 4x, that's 12x. So x then would be 180 divided by 12, which is, come on, Mousy, don't play. 180 divided by 12. That's 15 degrees, as Imani rightly said. But that's not the angle, that's not each angle, no, that's just the value of x. So each angle here then would be 4 times 15 degrees, since x is 15. So each angle is 60 degrees, and we should know that already because in an equilateral triangle, all of the angles are 60 degrees. We have 3 60-degree angles. So we didn't even have to work with the 180 this time. We could just say, to find the value of x, we could say, since we see this is an equilateral triangle, three equal angles, 4x is equal to 60. We could just work with that alone and we would get x equal 60 divided by 4, which is 15. So if we wanted to, we could have come this route rather than going using all of them. So we know all of them must add up to 180, but we also know that in an equilateral triangle, just this angle alone, or this one alone, or that one alone is equal to 60. So we could find it from there also. All right, so here's an easy peasy one. This is for the students who have gone to sleep and they need to wake up back. So here's an easy one. Easy peasy one, this one. How would I find angle B if this is 73.6 degrees? This is an easy one to wake up the sleepyheads who have dozed off. All right, so for the previous one, Trevor was saying to get the answer, you divide 180 by 3 because all the angles should add up to 180, so it's 60 degrees. Right, so each angle is 60 degrees, but we wanted first the value of x. So if each angle is 60 and then each angle is 4x, then x is 15 degrees. So for this triangle that we're looking at now, all right, so the elites is saying it's a right angle triangle, which is correct. So we can see that iconic square in the corner there, that perpendicular square, to tell us it's a right angle triangle. Trevor says we are to add the 73.6 and the 90, since the box tells us that that's a 90-degree angle. All right. And then he says, Ngozi says 90 degrees minus is 16.4, Ngozi? Where that 16.4 coming from? And Sajarta is saying 16.4, but where the 16.4 coming from? Okay, so 90 degrees minus 73.6. And Trevor said you'd get 162.4 and then you subtract it from 180. All right, so everybody on the right track. So 16.4